So both waves travel the same distance. So that means delta x for distance is equal to v1 t1, which is equal to v2 t2. Now we let the smaller speed be v1. So let's say v1 is the smaller speed, and the larger one is v2. So v2 is larger. So the slower wave will take longer time to arrive. So T1 is actually greater than T2 in our case, because T1 is slower. Sorry, V1 is slower. Um, Now that means we can write T1 being equal to T2 plus 1.5 minutes, which is equal to T2 in terms of seconds, it's 90 seconds. And from there, we can actually use this information over this equation. So we'll have V1 times T2 plus um, T2 plus 90 seconds is equal to V2 times T2. So from there, we can solve for T2, and we see that T2 is equal to V1 by V2 minus V1 times 90 seconds. So now using the given values in the problem, we have V1 as 5.5 kilometers per second. Divide that by 8.5 kilometers per second minus 5.5 kilometers per second, which gives also we need to multiply 90 seconds with that. So that finally gives us 165 seconds. So that means if we know the time, we can easily figure out delta x. So delta x will be equal to v2 times t2, which is 8.5 kilometers per second times the time, which is 165 seconds. So that equals to 1400 kilometers. So for part B, the information is not enough to determine the epicenter. All that is known is the distance of the epicenter from the seismic station, but we don't know the direction. So that means the epicenter lies on a circle of radius 1400 kilometers from the seismic station, and readings from at least two other seismic stations are needed to actually determine the epicenter's position. So to summarize, we cannot determine the epicenter because the information is not enough, and all we know is the distance of the epicenter from the seismic station, but the direction is unknown. So basically, the epicenter lies on a circle of radius 1400 kilometers from the epicenters from the seismic station. Excuse me. So readings from at least two other epicenter seismic stations are needed to determine the epicenter's position. All right, thanks for watching. I'll see you next time.